Welcome. I'm Bill Wake. We're here working on the 10th programming language. It's a subset of 4th. And today we're going to start working on secondary headers. It's part of the interpreter, and I think we have it slightly wrong. Okay, here's what I think is going on now. So we have this dictionary structure, and it contains the address of assembly language routines. So start2d, push, and end2d are the three we're using in this test. Sorry, let me have my computer glasses on. Okay, and then those are what we call primaries. They're assembly language routines. Then we have secondaries, and the secondaries, the first word is going to point to start2d, and the rest of it is a list of addresses of other words, either primaries or secondaries. Okay, same thing for secondary 2. So what I think we have now is the secondary one points to the address of the start2d dictionary, so that top row on the left. And then the second line, it's the address of the secondary, since we're just calling one. Our test is a secondary that calls secondary 2, which just pushes 55. Okay, and then we have the address of end2d in the dictionary, okay, which is sometimes called the word address of that routine, I guess. Okay, and then secondary 2 looks similar. The first row is the address of the start2d dictionary entry. The next is the address of the push dictionary entry. Then a literal 55, the value we're pushing, and then the address of the end2d dictionary. Okay, and this is what we've set up, I believe, and this is what's wrong. Okay, so that's now what I think we want. Okay, the problem is the primary header in the dictionary points to code like it's supposed to. The header of a word or of a routine is supposed to point to the code that corresponds. But notice our secondary, it has the address of the dictionary entry, which is not the address of the code. It's got one pointer too many. And so I think we're trying to dereference start2d dict as if it were a routine address, where it's really an address that contains a routine address. All right. And now the address of secondary 2, that one I think is the way it should be. And the address of end2d is right. It's pointing to a block of code with starting at the word address, which is an address of code. Okay. I think. All right, what I think we should have, I don't think we need to start2d in our dictionary at all. I think the address of start2d should be put in the secondary, since every one of them starts with an assembly language routine. So the address of start2d is an assembly language routine, and we'll put that address in the first row. The second row, address of secondary 2, that's right. Address of end2d in the dictionary, that I think is right. That should say DICT on the end, because that's going to be a routine that we're calling from a secondary, which means we point to the block for that code. In this case, that's the address of the method. And so calling it is one in direction to get from the address to the method itself. Okay. I don't think this will be terribly hard to fix. Let me fix this entry in case we ever have to refer back to this. Excuse me. Okay, I don't think it's going to be impossible to fix. I think mostly, we don't care if that thing is really in the dictionary or not, but we really have to get that address in the first line of the secondary. Okay. I still think you need a jump command. We have one. But I don't think we need it here. Let's see. Go back to Xcode. Okay, so jump is interpreter. No, I think it's core. So when we did the if, we did a jump. We did if true and jump. So is that the jump you're thinking of, or a different one? I don't think we need it for this test. We will for a test of the if statement, and we know that test is failing, and I'm pretty sure it's because of a similar problem. Okay, so man, we stared at this stuff so much. Okay, so what I think should happen, let's go look at this routine. Okay, that's in core test macros. Secondary start loads up these three addresses. Points to the secondary. I think it wouldn't hurt to. Well, honestly, I think our secondary start could put the address of the start2D right in one of the registers for us. And actually, no, don't even need to do that. It could just put it in the first slot at x0, just like everybody else is. They're storing stuff in at x0. Okay, so I think to make I jump for the secondary call. The only jump, let's see. I think the big option there. Let me get the interpreter. Is that our loop? No. This is some version of our interpreter loop. So the difference there is this BLR calls a subroutine, and then it branches back to the interpreter loop. The one jump I could see is take this out and move it to the end of everybody's thing. Instead of a return statement, they would all just branch back to the interpreter loop, and we'd have to make the name public, but that's definitely doable. So I think that jump would save us. What we do now is we do a branch with the link register to here, and then we do a return, and when we get back, we do a branch. Okay, so I'd like to have us directly jump in here, branch back here at the end. I don't know if BLR is going to be appropriate or necessary, or if it's just an indirect branch. It becomes an indirect branch. BLR sets that link register, but I don't think we're doing anything with it, because we're calling these things. There might be some routine that needs to do it, but not us, I don't think. But that's a future days issue, I think. Okay, so the thing I would like to happen is, well, why don't you give me start2D in the macro? And let's call it start2D label. Okay. All right, so what I think should happen, well, right now, this test is kind of complicated, or complicated by this. We pass in start2D header, because the header is where we're storing that address. So I don't think header is the best name for that, but probably a better name would be address. Okay, well, I don't want to get sidetracked by the address. Okay, but maybe we should be passing this in. Core test macros. Start2D. I'll say address. Okay. So, assuming you've loaded up start2D with the start2D header with the address of start2D, then I'm going to copy that memory from there to our code. Okay, and this is all still test setup, so I don't know. It's like, in a way, we're testing our test setup as much as we are the code, so it's kind of weird. Okay, so I'm going to take, well, what do I want to do? Let's do this first. No, we got to do it. We can't do it first. Okay, let's do it. Let's do it here. We're going to load that address into X2 from start start2d address. Okay, so that should be the address of where we want to look. I hope this is going to work. Okay, and then we need to store it. We're going to store x2, no. Okay, load address x2 should load the contents of start2d address, right? So we want to store x2 at x0 and move. Okay, I think that's what we want. All right, so the deal is we're going to boy, the ordering here is a little wonky. X2 is a temp. Okay. All right, so we're going to load X0 with the address of the secondary. So that's that first, points to that first slot. Then we're going to load X2 with the start2d address we're given, which is the address that contains the pointer to the routine. Then we're going to load, no, then we're going to store. Is that going to be right? I think we're loading the code at the value at start2 address into x2. Then we're going to store x2 into the first slot and bump the counter. Okay, and then we'll set up the secondary and the dictionary. Why I chose x3 for the secondary? That's bizarre. Okay, we'll come back. All right, but I think that's how I want to get that value in. And now these tests should not do this. That's part of the start. We're going to put that initial word in for you for start2d. So you won't have to reference start2d header. Same thing here. Okay. And then, well, we don't really need this. So let's change these 0, 1. You know what? That's probably stupid. Let's make our minimal change. This is kind of what I think needs to change. All right. We've saved. Just to be sure for today, I'll do a make clean and a make. Now, I think that if test is going to fail no matter what because he doesn't know what's going on. Okay. Start. In core tests. Why would core tests go crazy? That seems like the thing we haven't done. Where's core tests? We haven't touched it. He's got a start. It's global. Let's make core test.o. It's up to date. Okay. -e start. Yeah. arm64.0 core test.out. Okay. We'll touch core test.s, make core test.o, make referenced from start in core test.o. Undefined symbols blank. That's not really a helpful message. All right, let's look at start. Test all core tests. Test start. Now we don't call these macros in here, do we? Oh, we do. I don't see how that would do it though. Okay, let's try make interpreter test.out. back out some changes here. Interpreter tests. Core test macros. Have I spelled something or forgot a bracket? Start to address. Oh, I don't put this in. I need that. Interpreter test. Start dictionary. Start 2D header. Okay. What can I do to make interpreter tests? I don't remember my make file enough. Did I put a target in for? No, I just did tests. Okay. / interpreter test out. Bus error. Oh, I swear, it's like you have to be an optimist for this stuff, because otherwise, I don't know. All right, bus error. It's a different error than we had yesterday, for what it's worth. And the core test macros are busted because we don't take account for that start 2D header thing. All right, we'll save that one, but let's get in here. We'll set a break to start 2D. We'll dump this again. Make sure our data stuff hasn't really changed. 4100. Yeah, that's 4100 still. Okay. Let's run. Okay, so at this time, we should be able to do a mem, read, minus count, 420, I don't know what it was, 18, and this address. Okay. 3D98, 35F8, 3DB4. Okay. 3F58, 3F58. I'm not quite sure about that one. Oh, 3F58 is push. Good. Wait, why is this still here? 3D98. Three D 9 8. Oh, I left them in to be the same. Okay, fine. 3D98, but why isn't it 3D94 and 3DB4? B4, they're off. What's 3F58? 3F58 is push, and that one's not off. So these two are off, and this one's right. Oh, why would that change any of that? Okay, then this one's 4110. Okay, that's, wait, this is 4150, 41F0. can't quite reconcile this. Is the OG? I thought it was. Interpreter test dot out. Okay. What? That's a good question, though. Something's definitely funny. I mean, it does have that feel, doesn't it? Like it's something shifted by a byte or two, and now these addresses are weird. 3D98. Star 2D. Okay, that is good. 3D. Maybe you're right. Maybe I had not got current. 3D98. 3F58 should be push. 458 is push. 3DB4. And 2D. Okay. Yes, those look right now. Oh, thank you. All right. Now this one, 41F0. This should be secondary 1. I may have. I should do a clear between them. I don't know if that would help. Okay, so 41F0 is down here. And it points to 3D98. So this is our start 2D header. So I've loaded the contents of start 2D header, the address of start 2D header, not the contents of start 2D header. Okay, so I need another indirection. All right, let's do that. So we're gonna load address x2, contents of x2. Brackets not supported. Oof. Oh, maybe I can just do an LDR. Because it's all registers. I'm not dealing with addresses that we had to break up. And I found some documentation for the ARM assembler, not necessarily the CLang LLVM one that Mac is using, but it had other relocation operators. So it may be worth an experiment at some point. Maybe we can load these addresses directly into the data segment and not have to jump through these hoops. Okay, so now I'm loading the address. I'm loading the memory in that address. I'm storing that value here. All right, and we, okay. Do this again. Okay. Huh. After a week and a half of waiting. All right. So I think that's saying it works. Now, it may mean every other test of these things is not working at this point because they don't do it this way. But, well, that's major progress, assuming we're okay. I think I'm on top of it now, but I mean, I go through these cycles and, have these ideas, and I think this is about the fourth one, and now it kind of works, like, gosh. Part of it is I'm losing track of these pointers to pointers and stuff like that. Part of it is having to use register names instead of letting me use those in a macro is just crazy. If I were doing this for a real project, I'd be bringing in a real macro processor. I did take a look at M4 real quick, and I'd used it like years ago. I mean, 20 years ago, maybe more, for something. but and it kind of does things, and I couldn't quite remember how all of it worked and stuff. So it wasn't just sort of a little easy drop in, but um, I think that's okay. All right, so let's. Well, do I want to push this? I guess I'm worried that core tests code, these tests aren't right. But they're, on the other hand, they're not um, I don't think they're using the same mechanism, right? They weren't using any of this address stuff. Well, on the other hand, wait a minute. Why would they care? Oh, there is one. Okay. All right. Oh, our good old if. Okay. All right. I'm going to back it up. Let's take the if tests out. I think there's 2 or 3 of them. I guess the jumps too. Let's take those out briefly. Okay. So if I take these out, I think, well, let's make clean make. Oh, okay. Undefined symbols referenced in core-test.o. Oh, I still don't have them in the macro. I mean, I've got the macro, so it's not compiling. Okay. I'm going to take this out. I think we can remember this long enough to make it work. Jump. That should be one more. There. Okay, because we're misusing that macro. Okay. Yeah, let's see if we can get all these tests running. All of the tests are passed now. Okay. Yeah, the print number just prints, so it's a little weird for a test. But everybody else has an actual pass. Okay, let's, what do I call it, ACP? Oops, I'm supposed to pass a message. Okay. Reporting didn't have to commit. Okay. Make secondaries able to call secondaries. If jump no longer working. Okay. Long overdue. Okay. So how do I want to go here? Okay, I think let's finish that little bit of cleanup on here. We don't want start2d header in the test dictionary. Okay, so this becomes 0. This becomes 1. This becomes 1. This becomes 0 and 1. Okay. Nobody else using this? All right. That should pass. Again, I'm just kind of being careful. Oops. Okay. We remove start2d from dictionary. Changes not staged. Did I not build this? Something's weird. Is it show? No, I guess that worked. Okay. All right. So I think that's reasonable enough. We have to do these load address and just, yeah, those loads we do. Pass the secondary. Okay, I'm going to take this TBD off because I think that's what we kind of want to do. Check. This one bugs me. Let's see. So what we're doing is we're loading the value at the data stack, which should be the top value, but we didn't really look to make sure it was the top. And this is X19 is our virtual stack pointer. So I don't think it's wrong per se. The value did get there, but there's something about how it's there. Let's see. We don't do anything there. All right. So this gets set in run interpreter, sets that value. And then our push is core, loads this X20 push data. Yeah. Click control command click or whatever won't work. Kentucky, why would I have that there? Macro assembler macros. Yeah, I kind of think we should do pop data to get it out. We push it in increment, pop data pre-decrements. Okay, yeah, I'm going to say this test should do a pop data. Load address X0 data stack. Load R X0. No, I think this should be pop data. Pop data X0. So push load, move the contents of the top level of the stack into X0. That should do this. Was that what assembler did? He just does a load register. Maybe I'll mark these like this for a moment. My claim is this should also put the contents of X0 into the or it should put the contents of the top item on the stack into the stack. All right. Make. Okay. So I'm going to change something, make it wrong. Let's leave this instruction in. It should do like a bus error or something. Is that going to check? Okay. Segmentation fault, sure. All right. So I think he's out. Okay. Check that the stack contains the right answer. X0 gets that answer. The actual X1 is the expected. And we call assert equal. All right. And then just as a matter of spacing, I kind of want it like that. Indentation doesn't quite mean the same thing here, but okay. So that should be back to passing. Good. Yeah, that might be interesting. Yeah, let's keep that one in mind. I'll add it to our notes. This we use pop data. Yeah, or top. I mean, usually you call that top, right? Use pop data to check results. Okay. But yeah, let's make a peak data thing, or top. Actually, I kind of like the words flipped around anyway. But yeah, let's do that. Let's add a. Is that in here? Okay. Um, it's gonna be very similar. And we're kind of testing this by testing our tests. You know, it's a little funky. Okay, but the contents of X19. This is. This is the pre-decrement. Yeah, you're right. I think we can say it like this. Without the bang, it's not going to decrement. It's just going to offset it. I believe. Let's see if I got that on my notes. I mean, usually I get to an assembler and I know what I'm doing with it pretty, I mean, I get every little bit down, but after that intimidating 1,500 page documentation, yeah. So this is immediate offset, RN in brackets, RN value, it addresses it, in our case it'll be minus, versus what looks like the same, but it has the exclamation that pre-indexes. And if you put it on the outside, it post-indexes. Okay, I don't know if that's like where they got that syntax. Seems funky, but all right. But I think, yeah, to your point, well, and I'm going to change the name too. I said data top. That should get the pre-value, but not save the decremented value. Okay. This is data top. Good. Non-destructive peak. Yeah. Okay. Now, continuing, I guess I want to take, because we're back to green, I want to do a little bit of refactoring on things. I don't have grand plans or anything. Well, I could turn these two tests back on though. Wouldn't that be good? Let me finish that rename idea first. Okay. The name, because I think data push would be a better name. So I'm going to change push data to data push. Push data. Oh, we know where it is. It's in these two. Oops. Thought I copied that. Data push. And then pop data. Again, not very much, but data pop. Okay. Okay. welcome, Albert or John. Um, yeah. Um, we're working on a an assembly language interpreter for a semi-made up language that's more or less Forth, the old stack-based language, mostly popular in the '70s, but still used some. I saw pragmatic programmers have a book coming out soon about like they do 7 languages or 7 functional languages or 7 databases or whatever. They're doing 7 obscure languages, and Forth is one of them. Okay, so let's see. Give you kind of a quick intro. um, so the core of this thing, the core idea is um, everything is either a primary routine, which is like a simple assembler routine, or it's a secondary routine, in which case it calls other routines. Okay, so the primary, we're not using this exact dictionary structure. We'll get something closer later, but for now it's more like this. But the primary, the key thing is this address of code. This address here is called the word address, and it points to the code. Am I a software engineer? I suppose so. I call myself programmer more often. Mostly I'm not doing that stuff. Alberta from Florida. Okay. The secondary, it also has an address, but it's sort of the same routine for each secondary. It's called start2d. And then it has a list of other functions it wants to call. So it's all stack based. So if you had 3, 4, add, 3 plus 4 is 7. Okay, this would have, it has something that says number 3, number 4, push 3, push 4, and add. And then we're writing an interpreter that goes through, calls whatever's at this address, gives it this list of things, and then it walks through the addresses. So it sees a push and says, oh, your next word should be a number. Okay, I'll push it on the stack. Push again, next word should be number 4, I'll put it on the stack. Add, okay, that word is a primary. I'll go call this address. It says to jump here to the code, and I'll do it. Okay. All right, digital artist with artwork. Okay, so if you're not a programmer, this probably will stop making sense at some point pretty quick. But you're welcome here anyway, of course. Okay. Well, what we want to do now, I think that was the burning stuff I had for cleaning up things. Where I think we need to get is back to tests. Okay, now interpret empty program and secondary run. Well, let's just start with 1. Make sure this, oh, shoot. Okay, oh well. But that passed, good, okay. And then this one, I'm a little more nervous about this one. Oh, so let's do our, whoops. Get it passing again. I don't know how you do it, honestly. You can share a link if you want, I guess. Oh, yeah. Huh. Don't know. You have to post a pseudo link, I guess, Okay. All right, let's see. This one I'm a little more worried about. Try make instead. Oh, no, it's good too. Okay, good. No, I'm not really using either one of those. Sorry. Reactivate another test. Okay. All right, now I think we're ready to go. We've got our core tests. These are the ones that had the if tests. So let's take jump because it's the easiest. Now he's take that start 2D. Okay, start 2D. All right, we don't want to do this anymore. Oh no, we don't need that in the dictionary. But if I do that, it changes all the numbers. Okay, let's not do that first. Okay, 1, 5. All right, so our secondary start, we need an address for start 2D. I don't think we can just do start 2D here. Yeah, I'm kind of skeptical. Whoops. Oh, well, and I'm on the wrong test. Well, I'll leave it like that. It's probably syntactically okay. We're not going to run it yet. This one. I actually think it maybe should point to LTest dictionary. Okay, so that's in core tests. And what do we make? Jump segmentation fault. Okay. Well, that makes me wonder about our macro. It seems like I should be able to. Like maybe I can pass the start 2D label to my macro. Wouldn't that be an improvement? So if you give me that, that should load start 2D label. I think you won't need this anymore. The problem is we didn't have this third argument coming in. So I'm thinking core test should pass with this, but the other might not, or the other will not. Okay, so what I think we can do is, well, we're gonna have to take this out. But I think if we pass this label, our macro then can say load the address from that label, and then I'm not clear if it needs that loadr or not. It loads the address of start to label, and then it stores. I think. Let's try it. So this is for the core tests. It's not going to work. I'm changing it on the interpreter tests. Okay, it did not work for either one. But I think I'm on to something. Okay, right. So load address. I'll go back to my basics. Load address gets the location into the register. So maybe it is. Maybe it needs another layer. We have the address of that. I don't know. We'll see. Neither one works. Then we're going to have to go look at things. Super odd. Okay. These don't mind that, but they're passing in the interpreter. Whoops. They're passing in start 2D header, not start 2D. Okay, but I think if I do this, I think that's going to break my interpreter tests, which used to pass. I don't think it's going to have anything to do with jump, so jump's going to fail just as bad. Right. Okay, so something. All right, so let's. Well, this feels like a way to get something really nice out of it. Yeah, I know I have an account somewhere, but I just never go into it. It just got to be one too many place to look, you know? All right. I'll try and remember to look, though, after the session. Okay. Where am I? I'm interpreter tests, secondary end zeros, push header, that. Okay. So I think we're familiar with this one enough that maybe this is the one to do the debug on it. All right. So LLDB, interpreter tests, break set -B, start 2D, run. This time I'm going to do a clear and then a dump. I'll see if we get any blank space or something in front of the first one. Yeah, not really. Okay. Go to our data segment. Somewhere around 4100. Yeah, still 4100. Okay. Mem read -C. I forget what we said. 240 was too much, but it's still read. OX. Oh, not enough. Okay. Didn't I run? I said break at start 2D. Okay, I guess I'm there. Why is this still empty? I'm going to continue. Like, where's the stuff? Okay. Make sure interpreter test it out. Okay. Run. Now we've called run interpreter, so all our test data should be set up. Mem read minus C 350 OX. Oh, we're not on the right test even. There we go. Okay. All right. So 3F58, we know that is start 2D. Okay. And our number twos here. Whoa. Whatever that is, that's not right. Okay. So I guess I need to look at the start test macro. Let's see if this is what's in 3F58. Not really. 80, 86, 40. That has no relationship that I can see. Then 41A0, that's fine. 4108, that's this, that's fine. Okay. Wow. Check the code at that. It could be the code at that address. Well, that's what I was wondering, but 3F58 is the address of the start 2D, and its first few bytes are different than these bytes. Like, I don't see any relationship there. In reverse, okay. F90007. No, they're just different. Well, it's not the A0, but the F9. Yeah. That's why I think it's one dereference too many, maybe, or something. Okay, so the way to do this then, let's turn off these other two tests again. So I don't have to panic. Okay, and then we're going to break at the start, secondary start. Okay, so I'll say my break. Okay, so save, make, as I always forget. $4,100 again. Okay. Break set minus B, my break. Good. All right. And run. Okay. So we're loading X0. Oh, okay. So this is we're loading SS1 into X0, which makes sense. Then we're going to load X2 with run interpreter plus 28, which is probably start 2D. Yeah. Okay. So well, these are fine. So we'll step, 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 step. Okay. Now we can look at x0, x2 rather. 3D 98 is break for run interpreter plus 28, which is start 2D. That we don't want to do a load R on that then. Is there a skip? Oh yeah, no, it's all good. It's funny to me. Gosh, I don't know. The assembler, like I'm used to debuggers, even like Octal debugger, I can recall. You could go in, you could update a register, you could skip an instruction without executing it, you could do all these little things. And I'm not seeing those commands in this. It's very static view of it, which I'm kind of amazed it's not there. And maybe I've missed it in the documentation, but I did look around a bit last night too. All right, well, I think this LDR is wrong in this case, that we would have x2, x0 plus 8. Yeah, okay, so my hypothesis then is core test macros. This should not be here. Start label. Okay, so I'm going to quit. Yes, make. Okay, and that passes. This still fails. That's fine. Okay. Let's go back to our interpreter tests. So now you pass start 2D into start. Secondary calls. Oh, this doesn't do our way. Okay. That doesn't. All right. Sorry, let me do another make. Okay. I'm going to comment out that jump test again. What is his problem? Huh. Okay, well, let's comment it and then what do we call that thing? Start start secondary start. Okay. Hey, Mighty Coffee Mug, welcome back. Yeah, we're pretty low level today. You can tell when you look at a page of hexadecimal going on. So yeah, so we're doing a programming language called 10th that's an imitator of 4th, and we're working on the assembly language interpreter part. And I think we've got it basically working, but we got a couple things that aren't up to the way it works now. So we're trying to get those fixed up again. I'll share my picture I used a few minutes ago. So the implementation is you have, well, basically 4th is this kind of stack based language. So if you've ever used the old HP calculators or some other stack thing, to add 3 and 4, it's push 3, push 4, add. And when you do that, when you're calling other words or other functions like that, we have this idea of a secondary, and the body of it is just that list of addresses. The address of push, a value if you're going to push, an address for push routine again, another value, the address of the add routine, and then start2d is up here. It's an assembly language routine that knows how to walk through these, and it's kind of the core of the interpreter. The other ones you have are primaries, and that's just assembly language code. You have their address up at the header. So, oh, okay, cool. So you may know it better than any of us. But anyway, you have the primaries, the assembly code. And so the interpreter, it either calls this address and then calls this code, or calls this address and then start2d walks through the code. Okay, so, and we're working on the interpreter for start2d. I think we have it right because we just got secondaries calling secondaries. I want to get on to recursion, testing recursion, but if we've done everything right, and I'm so optimistic, I feel like we have, that should just work, but nothing has just worked yet, so it's kind of a foolish optimism. Okay, but we did get the main interpreter test working, but now we have the tests for jump and if, so our if statement has low-level routines to help them, and those need revising. Okay, so, okay, core tests. Let's push this one back in action. Okay, jump skips over code. All right, that's the last test. Okay, so I have some macros that build up a dictionary, and you just put the routine names in it, and it just loads a sequence of addresses. And then we have the notion of building a secondary. You call this to say, what secondary do you want to build? What's your dictionary? What's your start2d address? All right, and then this should, well, I don't see what's wrong with it, honestly. This is what we changed. You used to, reference start2d, and with this 0, this is 0, 1, 2, 3. All right. I think what we're going to do, we're going to do an assembly. I mean, we're going to do a debug on this. All right. So core tests, a make should run the core test and fail. Okay. Jumps over code. Yeah. The assembler is a little wimpy. The ARM assembler. But yeah, we're getting by. All right. So let's debug this thing. Core tests. Okay. And then we'll do this dump. Okay, so core test that out. All right, so we're going to break on our failing test. Yeah. Well, we're using Xcode. All right. Okay, so we're breaking at this test. I wish I'd let me do that. I'm gonna put a break me, and put this one. Okay. Make sure I've saved. Oops. Okay. Okay, we'll redump this. Okay, and we're looking for the code segment, the data segment rather. Well, it had been 4100. I don't know where it's going to be. Okay, so we're here. We're ready to start secondary start. Actually, you know, I kind of want to break it start 2D. um, and see how it's configured. No, let's. Okay, yeah, we can break there. But we're going to do secondary start, which is a core test macro. It loads address, which is 2 statements, and then it's going to load the label. All right, let's make sure our thing uses the label. Okay, start 2D. All right. And where is else test secondary? All right. Well, we're going to run. Okay, that's continue. Okay, we set a break at jump skips over code. Let's set a break. What do I call it? Break me? Continue. Okay, so x0 is going to get 0xb8. ADRP. So that's the page offset. XB8. I think I'm having another data section way up here somewhere. Now I would have thought. I don't see counts. We should see some data somewhere. $4,000. And we had been using 4100 in the other one, but we haven't run this test enough to know where to look. But I think this address should be the secondary, right? Yeah, secondary start is the secondary should be an x0. Okay, so let's step reg read x0. Okay, and then let's do a dump. Minus C 400 starting here. Okay, so everything's 0. Okay, so we have loaded address secondary. Now let's step. Okay, and now x2 should be the address of start 2D. (3F78 plus 28). Did I set the break up here? I don't know why it doesn't take the closest label. Okay, yeah, run address plus 28 is start 2D. Okay, so x2 is start 2D. All right, now let's do a step. So this should be the first thing in our code segment, our memory. So let's get that memory command again. We should see something non-empty in one of these. Okay, 1003F78, 3D. 3F78 is if true. Oh, I'm looking at the wrong one. I don't think it's going to matter because things don't jump around that much. No, it's start 2D. Good. Oh, okay. I don't have to make them global to set the breakpoints and stuff, but we do have to do a column. I don't know why. It's just weird. But yeah, kind of odd. Maybe. Well, no. Start 2D is a global label. Where's that interpreter? Yeah. I believe. Yeah, there. So I don't know why it doesn't pick that up. Okay. So, all right. So at least the beginning of our secondary is supposed to be 1 or 3F78, which is the address of start 2D, and it's the actual address of the code. Okay. So that seems good. Maybe I wonder if this should be 4 now or something because it's off. Let's find secondary address. Target stores the address of a secondary cell. Number with no pound. A times the cell number plus the address of the secondary. Can document this better. Well, let's at least put this one down a line. Okay, X3 points to the secondary. So I think that seems okay. It's taking the secondary plus 8 times the cell number and storing it. But it's being put in implicitly because before secondary start didn't put in this address, but the address of the secondary hasn't changed. I don't believe so. I kind of don't think it needs to, but let's continue our way through the code. Okay, so we're in secondary start. We just did this. And now we're going to load these 2 registers. Step. And it's funny, X3 equals X3 plus 8. Okay, that's okay. I think there's something wrong there too, but yeah, so right now I'm just trying to get the interpreter if we set everything up in assembly language. But once we have the interpreter working, I want to go back in and set up the sort of compiling step where it reads a line of words and looks up their addresses and builds the secondaries for you and then runs them. So, yeah, I mean, I think we're on episode 14 or something. So it's definitely, this would probably take us a session or 2 to catch up in Swift, something like that. But yeah, I want to get that all interactive. My goal from that is get it interactive enough that we can write a small application in this new language and set up a little test framework for that, and then do some small game or calculator or something. I don't know what. Yeah, I mean, if we did it in Swift UI, I think, Swift and Swift UI, it would be a lot faster than this, but that's I've just felt this urge to, I heard this technique years and years ago, and I've never implemented anything that way. So I just thought it would be a nice thing to try. And I'm definitely on a learning curve with assembler and the debugger and all that stuff in the ARM environment. Okay, so I believe we're just going to see load address X1. Okay, X1. All right, now let's look at X1. 4078. And what was our memory read? 40B8. Okay, don't know what that one means. X1 at this point. Oh, it should be the dictionary. Okay. Yeah, we're not really showing that. Okay, so back to the code for core test. Yeah, now we're going to look at secondary add. Okay, so that adds X2 with something times the dictionary. Okay. We'll step. The next one is secondary target. Okay, so let's see X. We should see X2, X3, and something. 28 is, well, what? 40, oh, is 32, 28. 28, yeah, okay, 28 hex is 40. No, it's not gas. It's what you get when you run Xcodes, which I understand is like the what do they call that? The well, it's LLVM, but it's the LLD. What is it? It's their assembler that works with the LL stuff. You know, their language stuff. It's almost the same as gas, but there's just enough differences to go like. So yeah, what do they call those? The LLVM, LL, whatever that compiler suite is. You know, blanking out. All right, so this should be storing the address of a secondary cell, the target of the jump. So the end result of this should be in our range. Oops, our memory here. It should be pointing a few instructions ahead. So it should be 40 something, 40C, 40D, something like that. Okay, so if I step and now look at X2. Okay, 40E0. All right, so I think all right, I'm gonna step again. We're storing X2 into the word. Okay. Yeah, and if we do our mem read, 40E0 is over here. Okay. Yeah, there's the 40E0. So this is start 2D, jump instruction, 4080. No. And then 40. Something's weird. Did we leave off? That should have gotten the dictionary entry for that. Oh, it did. That's dictionaries in the memory. Okay. All right. So we've gotten through the first three things. I'm gonna step through till we get down to this 205. Okay, so that's Well, it's a few instructions. Move x2, store x2, add x2, x1, 8 is 24. Okay, I think this is it. The data stack, x19 gets the data stack. That's this. x19 gets the data stack. Okay, so our memory should be configured the way we want it. So, and I guess I'm gonna have to start our. Let's start our memory read at 4,000, and remember that 40B8 is our start. 40B8. Okay, so 4,000. Oh, 4,000 not relevant. What's relevant is 4080. Okay. Maybe relevant. I don't know what that means. So here's 4080, here's 4088. So somehow this should be, I don't think our dictionary's right. Yeah, it's definitely weird. So 4018 should be, I mean, this should be, well, this is pointing to start 2D. That's correct. This should be pointing to the dictionary, the LTEST dictionary. Offset 0 should be start 2D, offset 1, jump, and so on. Our code is for 1 jump. He's saying 4080. There's our jump forward, and here's 4088. And these do not look like routine addresses. So I feel like our dictionary's wrong. The code loading looks okay though. E0 looks like the right place. 4090 is probably supposed to be N2D. Okay, let's compare. Let's check out this stuff instead. LTEST dictionary. Where is it? Okay, I'm going to give us another label. Dictionary label debug. Okay. 1, 2, 3, 4, 5, 6, 7, 8, it looks like. Okay, so we dictionary start, add. I don't think we got it any simpler than that over here. Dictionary start, LTEST dictionary is a fill instead of empty quads, no big deal. And I see more debugging stuff in here. Let's take these out. Okay, but I think debug data is a nice name. Let's use that up here. So the dictionary is right next to the secondary. Is that what we're seeing? Oddly, no. Right. Oh, and a bunch of zeros. Okay, yeah, there's a bunch of zeros. All right. Well, my other trick is these are going to get overwritten, so you can do like 1 or maybe -1, -2, -3, -5, -7, -11. These are my primes. 13, 17. So when we go look at that data, we'll see those negative numbers in there. Is that going to help? Maybe that's too cute. Okay, but we'll see some prime numbers. Okay, but wow, that dictionary just does not look right. What is the difference? Dictionary start, L-test dictionary. It's a bunch of empty, well, it's a bunch of quads we can overwrite. We did P2 align 3. Let's make sure we did something similar here. P2 align 8. Let's borrow that little trick. Yeah, exactly. All right. So that should change the address, but a test dictionary is room for a bunch of numbers. 1, 2, I mean, we said 8. We're only putting 4 things in there. Oh, I keep looking at the wrong test. Okay, but in any case, this is a bunch of data, debug data we called it. We're doing jump, skips over code, dict start, dict add, and so on. Secondary start, L-test secondary, L-test dictionary start 2D, and just make sure the order of things. L secondary, L dictionary, start 2D. Okay, that should be good. Okay, so we got debug data, and do we have a good place to break this? I think we want to do this before here, so we can examine that data. Hey, welcome, Arts by Natalie. So we're working on an assembly language interpreter for a programming language that's like Forth, which is a kind of oldish stack-based language. And we're trying to make sure our setup for our test is right. And it appears to be wrong, but it sure seems a lot like the other way we set it up, so I'm a little puzzled. Let me know if you want more explanation. I'll give you the quick 2-minute tutorial of what's going on. But we're working in assembly language, so it's a lot of low-level debugging, and it's kind of annoying. All right, I think I have a break me, and I can stop there, look at all this data, and see if the alignment maybe fix this so the dictionary starts on a good place and go from there. All right, so save this, quit this, we'll redo this so we can see the code, and LLDB core test.out, break set minus B, break me. Okay. And then we need to find our data section. Okay, so there's 4,000. This is a little weird. Those are assertion statements, okay. 4080 was where we were before. We'll see where we are now. Oh wait, there it is. 1, 2, 3, 5, 7, B, D. Okay, that's 17 in binary. So yeah, we're seeing these values. Okay. Well, good. That tells me 4100 is the place to look. All right. Mem read minus count 400, and then we'll do this. Okay, we haven't executed anything yet. This should just give us the, 1, 2, 3, 5, 7. What's B? 11. Okay. 11, 13, 15, or 7, 13, 17. All right. Only has 196. Okay, I'll just make that. Okay, so we're going to break after this is populated and look at it again. So I'll do a run. Okay, and we stopped. Break me. Okay, and now let's do that memory read. 4100. Okay. All right. Well, there's, where was it? 4100. Okay. That looks just totally random. And it's not scrambled or anything. What games do I play in my free time? I don't know, not much. I played what's the one with the plants and the zombies? I played that one last. Nothing fancy, just mindless, do nothing things. All right. How about you? What are you into? Okay. So 4100, I guess we can see the remnants here of 7, 11, 13, 17. So we filled the first 4 dictionary entries with something. What is the difference? I don't think we have to say extern. Like to get these, did we? What? Well, I asked what games you play, but kind of juggling things too much, I think. Yeah, let's see what these registers are. Read reg. Oh, no. Reg read. Oh, okay. Okay, that we didn't put in. That we didn't do. So those are just left over from getting called. Debug data plus 112. Okay, so that should be, that's where our next secondary would get written. So that's like here. X1 points to the start of the block. Debug data is here. Okay, I'm very puzzled. Why the same code should work over there? Did I leave out a header thing of some sort, or? Well, we went through this mess before in this test. Yeah, we didn't do this the same way. Okay, let's pull this in. I guess we can add it down to the data here. Okay, so we're going to borrow this code. This is all going to go away at some point, I think, but I think I'll be expedient here. Okay. last one. Okay, so before this, we have to load these addresses. And then our dictionary add, we put in the headers. Okay, now what do we need here? Start 2D, jump. Okay, so we need one for jump. Jump, push, entity. Okay. Share away. I know this one won't be for everybody. Okay, so there's jumps. There need to be the headers. Okay. Now, let's just run first. Oh, okay. Okay, start to D header, jump, header, push, header. X0, X2, start to D header, jump header, push header. Dict add, push header, dict add. Well, an Altus dictionary. Let's make sure that's the right place to put it. Yep. Well, the other thing we could do here is call run interpreter. I think that's what we did back over here. All right. And we'll make again. Messed up there just was the code of the different routines. Oh, you think it's the... Okay. Let's... So we've changed that setup a little bit. So let's go bring it back. Okay, and let's redo this. Okay. All right, so I'm going to go to Start 2D and look at the data. Okay. We'll run. All right, let's find our data segment. Well, 4,000, 4,100 again. Okay. The messed up address was a hex for the code of the different routines. Okay, 4100. That's looking better, right? That's the address of start 2D. 3F54. Three F38, 3F54 is jump. Okay. So we have start 2D, jump, push should be 3F18. Yep. And 3F94 should be N2D. 3F94 N2D. Okay. Yeah, so that looks good. Got our leftover prime numbers there. Guess we'll learn our primes and hex. Okay, now we're pointing here. This first word should be the start 2D address, and that looks like it is. Okay. Then we should have 4180 should be the dictionary entry. No. 4108. Dictionary entry for push. 4168 is the address we're going to skip over to. Yeah. 4168. Oh, sorry. That's the address we're going to skip over to. Then 4110 is, that was jump, or one was push, one was jump. I don't remember which was which. Jump, then push. Okay. Push. And then 4118 is N2D. Yeah, so that setup looks right. And maybe the jump code is not correct at this point. I don't know. And then what's this down here in 4190? I mean, it looks like another secondary. But, okay, so we're... All right, and let's look at the registers. Reg read X19. Reg read X20. Debug data plus 72. Well, debug data. Okay. Plus 8, 16, 24. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 72 is 8. So X20 is pointing at our secondary. Which I think is right. And let's look at X0. Data plus 112. I think that's still the next place we would write to. Okay. Let's break at jump. Make sure I got the latest. Jump. Well. Oh, I think it doesn't like the underscores. It ignores them. Yeah. Okay. And if I continue, we should get to jump, which is our X20. Where are we? Run interpreter plus 44. Oh, bad access before we even got there. Well, we haven't taken our break today. A real break, just long enough for me to flip a chicken. Let's take a 3 or 4 minute break and see if we can come at this clean. But somewhere between the start 2D and the jump, something got, basically this is a null pointer exception. All right, see you in a few minutes. Welcome back. All right. Okay, so between the start 2D and the actual getting to the interpreter, to the jump, we never got there. So load our contents of X0. There's our 0. Oh, I don't think are we setting that up right? So this goes back to interpreter. X0 is the contents of, let's see, X20. $41.80. $41.80 is certainly zeros. Is that our jump? 41, am I twisting it? No, 41.80 is zeros. Why were we at 41.80? I mean, I think our routine is here. Push. Wait, is this push? Oh, this is the jump. 41.68 is here. Okay. Yeah, so basically we're saying jump, and if you don't do the jump, then we do a push of 17, it looks like. But we're not even getting to the jump. X20 should be pointing 41.80. He's just so far away. No, this test is not even if. It's only a jump test. So probably should have walked through the test first. Wouldn't hurt. Okay, so we load these headers. We create the dictionary. We create the secondary. And oh, I changed the wrong stupid thing. I think I just wanted to call the interpreter. Did I change the wrong method? Yes, I did. Golly. Okay, because I didn't trust the way this code started up. When we have a run interpreter method, it's supposed to encapsulate that. Okay. But yeah, so this code, oops. So it does, well, this is 1, 2, 3. Nobody's going to call 0 anymore. Okay. So he does a jump to what should be row 5. 1, 2, 3, 4, 5. Maybe he's only getting here, I wonder. But jump to row 5, which should be here. If you don't, then he does a push of 17. Okay, and so the stack should not have increased, which it would have if there was a push. Okay. This is very suspicious to me. I mean, it seems right. 4168. Yeah, this is the push. This is the 17, and 4168 is right here is the N2D. Okay, let's build again. Ugh. Ah, okay. Gosh. So yeah, we had two problems then. So one was the way we call the stack. I'm sorry, the way we call the interpreter. The code we had was probably correct at some point, but run interpreter is the real way. It just sets the stack pointer empty and sets the x20 to x0. So you have to set x0 going in, and then run interpreter does the rest. Okay. Okay, now I'm going to clean this up a little. I'm going to take this out. I'm going to renumber these. This goes down by 1. That stays the same. Goes down by 1. Goes down by 1. Okay. And no need for this. Okay. That should still pass. Okay. Okay, cool. Now, I noticed we seem to have recommented out our interpreter tests. Let's get those back in. Yeah, that's one of the other things I kind of wanted to try with this was making TDD work in assembly. I worked as a compiler engineer at Digital, which became Compaq, which became HP, for a number of years, and we didn't do TDD in assembly language there. We did a lot of tests. We were one of the compilers I worked on was COBOL, and they have a formal validation suite. And then C compiler didn't have one, I don't think, at that time. I think it might now. And then Fax macro or Alpha macro assembler, but that wasn't written in assembler. Okay, so re-add missing tests. Okay. Well, fine. Trying to find a useless change. Yeah, fine. All right. So we are back to the if tests. This still... I think the dictionary is jumping through hoops it doesn't need to. Why can't dictionary add just take the regular label? Why do we need this little extra table? Yeah, back to green. Yay. Unfortunately, we have tests that aren't working that used to work, but I don't know. Maybe getting them working again would be the better step for now. Okay, let's do that. We'll try if 0 does not jump. See if I can edit the test I think I'm working on. Okay. Yeah, we're going to, x1 is 1. Data is 1. I've left myself not able to make sense of my test, I think. x1. Oh, I'm pushing something on the stack. That looks a lot like push data. Data push. Store a value of a register in X19. Cordes. Okay. Well, let's get the interpreter running the right way. I think that's these three. Okay. This is... Why are we pushing this on the stack? Data is 1, should not skip. Well, it seems like our test should make that decision. All right, so address 1, 2, 3. So add is, if true, target 5. Okay. So jump. Otherwise we're going to add 2. Sorry, we're going to push 42. I still have this target 5 thing, still kind of throws me off. I think he's saying jump forward 5 instructions. 1, 2, 3. What? Okay, let's see this one down here. 5. That's supposed to go here. What is secondary target doing? Stores the address of a secondary cell. Cell number is the target of the jump, a number with no pound. Yeah. But it seems like the test could push that value just as good as we can. I'm not sure why we would... Well, that explains why they didn't call run interpreter, because run interpreter resets the stack. Okay. So my explanations are not very good. Okay, I'm going to get this one. X0 is address in the new secondary. Yeah, okay. So let's check this. Sorry, take this out. All right. So I think what we're saying is the one is if true. We're gonna put more stuff in here. Secondary add push with data 7. Okay. Okay, so we push 7, we check it. If true, we jump 5, whatever that means, which presumably gets us down here to N2D. What the heck is 5? I could see jumping. Oh, is that slot number? Okay, so we just added 2 lines, so I guess this is going to have to be 7. 0, 1, 2, 3, 4, 5, 6, plus the other one is 7. Okay, so yeah, we're doing an absolute jump to line number in the secondary, but 0 is implicit. So 0 from the start. L-test dictionary and start 2D. Okay, so push 7, jump if true to 7, which should jump down here. Otherwise, push 42, and then we're going to take this out. And then we're going to do, let's do peak address, or data top into x0, and it should be 7, right? Which jump is this? Does not jump for non-zero value. Now I'm confused. Apparently this is saying it jump if true, or if true jumps if false. It gets flipped somehow, I think. Core. Okay, if true. And I know I was confused. I think the labels don't help anything here either. But if the value is true, sorry, if it compares equal to 0, that's false, and we go down here. If it's true, we skip over the value and execute it. Okay. I'm not sure I can bear to deal with APL, but small talk might be kind of fun. Yeah, I mean, I don't know. This is it'll feel so good when we stop. All right, so we're skipping over the target, that target thing, that tells how far where to jump to, as opposed to the false case where we actually execute it. So, oh, you're right. 7 should be consumed. Yes. Okay, so, whoops. So, okay, so we have 7 on the stack. That's true. It should look at this and say, the value is true. I'm going to skip the jump, and I'm going to push 42 on the stack. And if I don't, okay, and so yeah, this should be 42. Okay, because that got popped. Okay, that so far seems good. All right. Can't quite see. Oh, the time. All right. Why my build is saying 435? Oh, that's old. Okay. Let's get that dictionary stuff up here. I don't know. This has to go. But we'll get it, and then we'll deal with it. Okay, so our dictionary, before our dictionary, we have to do this. So we need if true. If true header. Push and into D. Okay. And now this is 0, 1, 2. So this is 1, 0, 1, 2. Okay. So this is if 0 does not jump. We reactivated that. Okay. So in a perfect world, this just works. Okay. Should be 7. Yeah. All right. Segmentation fault. Okay, I guess first we'll look. If 0 does not jump. Okay, so we load if true into if true header, push into push header, into D header. We do the start. If true, push into D. Yeah, we chose the wrong one. 147. Oh, thank you. I don't know why it loses tabs when you paste either. That's kind of annoying. All right, but that's promising. Okay. Eagle eyes. Good. All right. Good, but not good enough. My troubles are deeper. Okay, 1 is push. 7 value. 0 if true. Target 7. 0, 1, 2, 3, 4, 5, 6, 7. Add is 1. Push 42. Okay. That looks right to me. L-test secondary is the thing we're creating. Okay. We did this the right way. L-test secondary. Data top x0. So that should look at the top of the stack. It should be equal to 42. Okay, and the error we got was segmentation fault. All right, well, I think we have time to look, to jump in. Break here. Actually, I think we'll, yeah, let's break there, and then we'll set a break for start 2D and examine the data. Okay, so where do I want to break? Is that good enough? I think so. And core test did get compiled, right? Yep. Okay. All right. Break sets. Okay. This core test. I don't think we should have changed the numbers too much. 4100. Okay, still are. Okay. 1, 2, 3, 5, 7. Good. Okay. We're going to continue. Whoops. Run. Okay, that gets us to the start of our method. We'll continue to get to start 2D. Okay, and then we want to look at our memory again. Okay, so 4100. Well, that looks just as bad as our other thing did at some point. What did I leave out? If true header, push header, N2D header. If true header, like that. Okay, good. All right. Let's take this, get our next test. We need to do that here. Activate the test. Okay, we got jump header. Wait, is that the one we did? This is the one I have to do. This comes out. That comes out. These become header. If true, push N2D, kind of like the other one. These decrease. So this is 0, 1. Okay, I'm going to decrease them and then we'll look at them. Okay. Secondary add 0, so we need a push. Push. And then the data. Zero. Okay, so we're going to push 0. Call if true, which should fail, so it should take the target. 0, 1, 2, 3, 4, 5, 6, 7. All right. We're loading test secondary. X0 on the stack. Again, well, okay, that one actually is kind of right. So this value gets popped to evaluate it. This value should never get added, so the stack should be back at data stack. Okay, I believe that. Now, is there something else missing? It kind of looks good. All right. It does it. Okay. ACP. Make if tests work again. Okay. But, so I think what I'll do, we spent so much time doing other stuff. Okay. We got secondaries calling secondaries to work. And then we restored and fixed the if tests. which seems like a lot. Okay. Yeah, so I think we figured this out. We picked up debugging. Secondary call to secondaries, yes. Tomorrow we'll check recursion, and we got to get some refactoring done on refactored dictionary setup. You shouldn't need to reload those and those. Okay. Yeah, I'm actually spelling out arrange act assert, which I never do, even though and that was basically my acronym I invented, and usually I never use those words except to describe it. Okay, but I think that gives us somewhere to pick up for tomorrow. This is in the way for every test, right? We've had to do it 4 or 5 times now. But I don't know. I think we can just make it so that our dictionaries don't call that header, shoving the header in the header thing. I think that was from when we were having too many layers and too many levels of thinking I needed another layer of indirection when I really had to get rid of a layer of indirection on one thing. Okay, well, thanks for joining me today. As always, getting through debugging these crazy assembler things is something else. I feel like I'm getting at least used to what to look for in it, and we're getting good at spotting when we got too far in the addresses or not far enough, and the value in the data setup. We're getting used to reading those. My hope is if we can get recursion done and switch over to the broader system level interpreting, parsing, kind of a compiler basically, then I think all our future tests can work at the language level and not down here at the assembly level. And I think we'll see an uptick on that. Okay, well, tomorrow, same time, 2 to 4:30 Eastern Time or 7 to 9:30 p.m. UTC. And thanks again. Have a good night, and I'll catch you sometime in the future, I hope. Bye-bye.